If you're asking what's the best model, then you're asking the wrong question. Yes, you can view the latest performance benchmarks and choose the most powerful model, but doing this is one of the fastest ways to overspend on AI. Slow your system down and even get subpar results. The right question to ask is, what's the best model for my specific use case and needs? In this video, I'll show you how to make this decision and consider the key factors that involve the trade-offs between capability, speed, cost, and security, along with examples from all the big players. The first and arguably the most important question is simple. Is the model's output good enough for the job? Different models vary a lot in how well they understand complex instructions, follow business rules, reason through multi-step problems, produce consistent repeatable answers, and larger models generally deliver more intelligence and better performance on complex tasks, but at higher cost and slower response times. For instance, OpenAI's latest model, GPT 5.2, can tackle complex high reasoning tasks with high accuracy. But the trade-off? It's expensive to run. Currently it's $1.75 per million input tokens and $14 per million output tokens. And it also has a higher latency. OpenAI addressed this by offering smaller siblings like GPT-5 Mini and GPT-5 Nano, with the latter charged at just $0.05 per million input tokens, 35 times cheaper than GPT 5.2. These leaner models sacrifice some reasoning power for speed and affordability, making them ideal for well-defined or high-volume tasks that don't require the absolute best intelligence. Speed matters, but how much of it matters depends on the use case. Real-time interactions like chat, voice assistants, or UI feedback need fast responses. Background tasks like reports, analysis, or overnight processing can tolerate much slower models. If we take Claude Anthropic as an example for this, some models are extremely fast but less nuanced, like Claude HiQ 4.5. Some are slower but much better at reasoning and accuracy, like Claude Opus 4.5. And some are more balanced, still able to excel at complex reasoning while maintaining reasonable speed and cost, like Sonnet 4.5. In many systems, the best answer isn't one model, it's a combination of models. Fast models for simple tasks, more powerful models when deeper thinking is required. This choice essentially allows the model to think longer to improve results when needed. Another key factor is something called the context window. That's simply how much information the model can look at once. This matters if you want the AI to read long documents like contracts or reports, remember long conversation history, combine information from multiple sources, and carry out complex coding tasks with full understanding of the codebase. For example, a simple FAQ chatbot needs very little context. An AI reviewing a 40-page proposal or analysing months of emails needs a much larger context window. Models with larger context windows, like Gemini 3, which has a 1 million token context window, against a standard window of around 200k for modern models, are powerful, but they cost more, they can be slower, and often they are unnecessary. So it's best to match the context size to the real workflow. Another consideration is whether to use a general purpose model or one specialized for your task. General models like GPT 5.2 or Claude Sonnet are performant across many tasks from open-ended Q&A to coding help, but specialized models can outperform on specific tasks. For example, OpenAI provides coding optimized variants such as GPT 5.1 Codex Max, and certain models specialize in other areas such as image models like Gemini 3 Pro Image or embeddings models for vector databases. There are also open source or open weight models that you can fine-tune for niche domains under a permissive license. Specialized models can be more cost-effective for a given task, but they might falter outside the domain. It's worth considering whether a one-size-fits-all model is preferable to a mix of models, each tuned for specific jobs. We've already touched on the variance in cost between different model tiers, but if budget is a major concern, it's worth exploring alternatives to the big-name frontier models. OpenAI and Claude's top models charge dollars per million tokens. However, some other providers focus on cost efficiency. For example, DeepSeek's third generation model, DeepSeek v3.2, offers competitive performance at a tiny fraction of the cost, about 28 cents per million input tokens and 42 cents per million output tokens. This is an order of magnitude cheaper than GPT 5.2 or Claude for generating text. The trade-off is that ultra low-cost models may not match the absolute accuracy of the more powerful models on the hardest tasks, and those providers may not provide the same security guarantees as the big players. Nonetheless, for many applications, a well-tuned, inexpensive model can handle the job well enough at huge cost savings. It's wise to compare pricing and performance benchmarks. Sometimes a slightly less powerful model can reduce costs by 5 to 10x while still meeting your needs. For many businesses, data location is very important, as there may be regulatory or insurance requirements around keeping data in a specific region, like GDPR for UK and EU. Some AI providers, like OpenAI, on certain plans allow you to choose where your data is processed and ensure it never leaves a specific jurisdiction. This can be especially important for industries like healthcare, finance, or government. Some model providers don't offer the same flexibility, so it's important to make sure your data residency needs are met. Closely related to this is security more generally. And the key questions we ask include: is customer data stored or logged anywhere? Is it used for training models? Can data be isolated per customer? And are there any enterprise-grade security controls? For internal tools, the risk tolerance might be a lot higher, but for customer-facing applications, the expectations are a lot higher. This often pushes us towards enterprise offerings and cloud providers with strong compliance frameworks. Most people default to using an LLM provider's API, meaning the model runs on the provider's servers and they just send requests to it. But many businesses already have their environments set up in platforms like Microsoft Azure, AWS, and Google Cloud. And it's possible to run the models in here too. This is worth considering because some models natively integrate with certain clouds. Identity logging and monitoring are also easier when everything lives together. If you're ever in doubt, it's wise to start with a high-quality general model like GPT-5 and evaluate how it performs on your task. Then decide whether to upgrade even further to a more powerful reasoning model for harder challenges, or downgrade to a smaller, cheaper model if you find the task doesn't need that level of sophistication. Then repeat the process until you find the sweet spot. Very often, testing reveals that cheaper models are more than sufficient. It also reveals expensive reasoning models only add value in specific cases. And it's also worth noting that getting the prompt right is often more important than the model choice. As newer models are released and existing models are made cheaper, the ideal model for your use case might change over time. So it's worth reevaluating this periodically. So we've determined there is no best model. It's just the best model for your needs. By understanding modern model types and their trade-offs like quality, cost, risk, and fit, you can select the right tool for the job, getting the accuracy you need without paying for excess capacity that you don't. If you want help choosing, testing, or designing the right AI setup for your business, that's exactly what we do. If you found this video helpful, please like and subscribe and drop a comment below with your specific use case. I'm Dan from Dan and Bob AI. Thanks for watching, and we'll see you in the next one.